Okay, example 1 asks us to find the domain and range of the function defined by y equals x squared minus 3. Use set builder notation, interval notation. We'll worry about what those mean in a moment. We'll first identify domain and range, figure out what they are. So, the word domain, when we're dealing with a function, represents the input values that are allowed. So in mathematics, when we're dealing with an equation, an xy equation specifically, the input, the domain, has to do with x. And we have to consider the type of thing we're dealing with in order to establish domain. Okay? If we are square rooting things, if we square root x, we can't take the square root of a negative number. So when I say that is allowed, we have to consider what are we allowed to take the square root of. We can take the square root of 0, we can take the square root of positive numbers, but we cannot take the square root of negative numbers. So when we're trying to find input possibilities, what would make the radicand, the number underneath the radical, negative? Okay, if we're dividing and x is on the bottom, we can't divide by 0. So again, a domain allowance situation would be if we're dividing by something, we cannot divide by 0. So what values would make the bottom equal to 0? When we have an equation like this, y equals x squared minus 3, I'm just looking at the x and asking myself what's happening to x. X is being squared, so right now I'm going through my head, what numbers are allowed to be squared? Can I square positive numbers? Sure, 5 times 5 is 25, 4 times 4 is 16. I can square those. Can I square 0? What's 0 times 0? So we can square 0. Kind of pointless, but we can do it, right? Can we square negative numbers? No. Negative 2 times negative 2? Yeah. Makes positive 4. Sure, we can do that too, right? So squaring numbers is allowed for all types of numbers, right? Can we square fractions? 1/2 times 1/2? 1/4, yeah, that's possible. Square decimals, 0.2 times 0.2, 0.04, yeah. So that's kind of the thing you want to look at. What can I do? What am I allowed to square? So I can square anything. What type of numbers can be subtracted by 3?
6, 9, and
5, negative 2, 1/3, 100,462, right? So positive numbers, negative numbers, 0, 0 minus 3 is negative 3, fractions, 1/2 minus 3 is negative 2.5, decimals, 0.5 minus 3 is negative 2.5, right? So I can square anything, I can subtract anything. Okay, so I'm in a situation here where I'm allowed to do anything I want to with any numbers I want to. Okay, so when that happens, so if there's no restrictions, domain equals all real numbers. Okay. That's the domain a lot of times. We're dealing with some sort of a function. I can put any number I want to in. Put in fractions, I can put in decimals, I can put in whole numbers, integers, 0, negatives, positives, whatever. All right. All real numbers can be put into this function. Now when you're doing input values, that's all you care about is the structure of the thing. So the other things that might happen, division of x. To find domain, we're going to have to say denominator is not equal to 0. So to get a domain when there's division happening, the denominator is not allowed to equal 0. If there's a square root of x, the radicand must be greater than or equal to 0. Those are other scenarios that might happen for domain. Let me give you an example of both of those. So I'll do this one in black. If I have y equals 4 over x minus 3. What value of x in 4 over x minus 3 makes the bottom equal to 0? What minus 3 equals 0? 3, right? Sometimes questions are easy, so don't I think it's 3, but I don't want to say it and look dumb, right? But yeah, x minus 3. So 3 minus 3 is 0. So this case, there's division by x. So x minus 3 is not allowed to equal 0, which means x is not allowed to equal 3. That's the domain of that one. Okay, again, all domain's telling you is this is what x is allowed to be or this is what x is not allowed to be. That's all domain really is. As long as x doesn't equal 3, I can evaluate that. If x is 0, 4 over negative 3 is negative 4/3. If x equals 5, 4 over 5 minus 3, 5 minus 3 is 2, 4 divided by 2 is 2. Possible, right? But if x equals 3, 4 divided by 0 is not allowed. We can't divide by 0. Okay, I'll do this scenario in green. Y equals the square root of x minus 3. Okay, square root of an x expression. This says the radicand must be greater than or equal to 0. The radicand is what we're taking the square root of. X minus 3 is greater than or equal to 0. Again, that's all you have to do to find domain. Apply the rule. If x minus 3 is greater than or equal to 0, and I want to solve that, I simply slide the 3 over, change the sign. X must be greater than or equal to 3. There's the domain. That's fine. That's a technical glitch. I can handle that. I didn't do it again. Math calculation errors. So again, these problems aren't the same as this problem, but again, it's just, that's what you look at for domain. What's the structure of my equation, and what type of rules exist for this equation? So for the one they gave me, x squared minus 3, I'm allowed to square any number. I'm allowed to subtract 3 from any number. So the domain of this function is all real numbers. Does that make sense?
Yep.
All right, I'm going to go new page here. Go side to side. So now it asks to use set builder notation or interval notation. All right, so here's what set builder notation looks like. That's set builder notation for all real numbers. Let me interpret this for you real quick. Go back to one page and just go like that. There we go. So to do set builder notation, let me just ungroup real quick. The red part, a bracket or brace with the letter X and a straight up and down line, and the end bracket or brace are always part of the set builder notation structure, and then the answer goes next to it, or in there, right? After the bar, before the bracket. All right? And this blue writing here translates to X is an element of the set of real numbers. So we're describing X for domain. That's what this is. This is the set of all X such that X is an element of the set of real numbers and set. That's set builder notation. That's going to be your less enjoyable one. It's not hard to do. It's just a lot of symbols to write down. All right? Here is interval notation. You're going to like this better. All interval notation is saying everything from here to here. If it's all real numbers, you're starting at negative infinity, ending at positive infinity. That's interval notation. Domain equals everything from negative infinity to positive infinity, which is also the way of saying all real numbers. Okay? So that's domain. Go to my other page, do range. Range is the output values when domain is used. And that has to do with y. We've got this list of x's we're allowed to use, and we're asking what type of answers come out of this function. That's what range is. When I put in the x values, what values do I get out for y? The easiest way to do this is with a table of values. Make an xy chart, you pick x, you solve for y, and you make a determination based on that. So let's take a look at this one. Anytime I have all real numbers as my domain, I usually pick those values for x. They're small, they're easy to work with, they're easy to evaluate. Now, we're recalling what we dealt with last week when we were doing a little bit of review work, and we're doing functional values, right? When I substitute a negative number in for x, whatever's happening to x has to happen in the entire value, right? So I might even make a three-way chart here where I've got x there, I'm going to have x squared minus 3 here, and I'm going to have y here. So 3 columns, where the middle column is simply the expression that y equals. So that's what y equals right there, x squared minus 3. Okay. For me personally, when I'm putting in x squared, I square it in my head. And I remember that x squared is always positive no matter what x is. If x is negative, x squared is positive. If x is 0, it's 0. If x is positive, it's positive, right? So negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. In each case, x is squared, then subtracted by 3. So as I'm replacing x with the values over here on the left, I'm evaluating x squared here, and then again the minus 3 is just part of it. So now I'm just looking at a simple subtraction or addition problem here. 4 minus 3 is 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 4 minus 3 is 1. So if I'm considering these answers, and I can just do a rudimentary graph here just to kind of get a picture of it so I can see what it looks like. I've got negative 2 comma 1, I've got negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, positive 1. It looks like it's going up, right? It looks like negative 3 is the bottom, right? So without knowing how to graph a parabola, which is what this is, just by picking those values, I very easily see that it looks like the lowest point on that graph is negative 3. Does it go below negative 3? No. Negative 3 is the bottom, right? One thing about a quadratic function, this is what this is. When x is to the second, it's called a quadratic. There's symmetry. If you find the symmetry, the middle is the bottom. So there's symmetry there. This is in the middle of the symmetric points, so that's the bottom. Or the top if it goes the other way. Sometimes they turn this way, sometimes they turn that way. So this is actually what the graph looks like here. Just wanted to connect the dots. Okay. Range is about output, what comes out. Well, what comes out is numbers negative 3 and bigger, right? So if I'm doing set builder notation, I'm going to write range equals the set of all y values such that, right? So again, just like set builder for x, domain's a set of x such that, it has the answer right there. Set builder domain's a set of y such that, and then we just put the answer in, y is greater than or equal to negative 3. You simply describe inequality-wise what that function, what that output is. The answers are negative 3 and bigger. Range is about this, domain's about that. All right, interval notation. We're starting at negative 3 and going all the way up to positive infinity. Now, real quick on set builder, notice I'm using parentheses, I'm using brackets. There's a difference as to why I use them. All right? When I use a parentheses, that means I don't want to include that value as part of the set. That's the stopping point, but I'm not including it. When I use the bracket, that's the stopping point, and I am including it. So this says -3 is part of the answer. I can see -3 is part of the answer. Right? Infinity is never part of the answer because it's not a definite place to be. So always use a parentheses for infinity, but for numbers, you can use a bracket if you want to include the number, use a parentheses if you don't.